Very good morning, students. Today we are going to discuss about working principle of DC generator. Okay, the basic working principle is Faraday's law of electromagnetic induction. So, what is that? A conductor moves in a magnetic field. It cuts the magnetic lines of force, which induces an EMF. Correct? I already told to for the for the EMF to be induced. Two ingredients சொல்லிருக்கேன். What are the two ingredients? One is conductor, another one is magnetic field. So EMF வரணும்னா there should be relative motion between these two. இங்க என்ன movement ஆகுது அப்படின்னா physically the conductor is moved in the magnetic field, hence EMF is induced based on the Faraday's law of electromagnetic induction. Correct? So the magnitude of the induced EMF depends upon the rate of change of flux, how fast it changes, or we can say how fast the conductor is rotated and how many conductors are included here. Like that, it depends on. Okay, the principle is based on Faraday's law of electromagnetic induction. Correct. So EMF is only induced in the conductor. If the conductor is in closed path, then there will be a flow of current. Correct. Flow of current இருக்கணும்னா closed path இருக்கணும். அப்ப அந்த conductor வந்து load-ஓட connect ஆயிருந்துச்சுன்னா there will be a flow of current. The direction of current is um, determined by the Fleming's right hand rule. Okay. So we have two rules. One is Fleming's right hand rule, another one is Fleming's left hand rule. Here, no, very interesting thing. This is for generator and this rule is for motor. In both the cases, we use three fingers, thumb finger and forefinger and middle finger, where all three represents in both the cases same. Okay, this is the direction of force. See here also motion, force, and then direction of field, thumb finger, direction of force in the both cases, and forefinger, direction of magnetic field in both the cases, and the direction of current in both the cases. See here, direction of current in both the cases. The only thing is what is determined in the case of generator, what is determined in the case of motor. Okay, so see here, in generator, no, we'll have magnetic field. Okay, in both the cases, the fixed one is magnetic field. Okay, motor or generator. Correct. This is the generator and this is motor. In both the cases, magnetic field will be there. In generator case, we apply the mechanical force. Correct. Mechanically, um, we give rotation. Correct. So there will be force. So these two are there. So we have to find out the direction of current. Okay, this will be the direction of current. All these three are perpendicular to each other. Correct. So direction of current is found out with the help of this Fleming's right hand rule. But in the case of motor, no, see here all the three fingers which are perpendicular to each other are representing the same three quantities. But here, no, the principle is when a current carrying conductor is placed in the magnetic field, it experiences a force. Now, in the motor, to find out the direction of force or displacement of the conductor, no, we use this left hand rule. Okay, it's very simple to understand the difference between right hand rule and left hand rule. And the right hand rule only is used in the generator. To remember this, எப்படி ஞாபகம் வச்சுக்கலாம் அப்படின்னா ஃப்ளமிங்ஸ் ரைட் ஹேண்ட் ரூல். எத்தனை ஆர் இருக்கு? ரெண்டு ஆர் இருக்கா? ஜென்ரேட்டர்லயும் ரெண்டு ஆர் இருக்கு. கரெக்ட். ஸோ ரெண்டு ஆர் வந்ததுன்னா ரெண்டு ஆர் வர்ற ரூல் எது? ஃப்ளமிங்ஸ் ரைட் ஹேண்ட் ரூல். ஹியர் நோ ஃப்ளமிங்ஸ் லெஃப்ட் ஹேண்ட் ரூல். எஃப் எல் ஹெச் ஆர் ஒரு ஆர் தான் வருது. ஸோ வி கேன் அப்ளை இட் ஃபார் மோட்டார். ஸோ மெனி ஸ்டூடெண்ட்ஸ் கன்ஃபியூஸ் வித் தி ஹியர் ஜென்ரேட்டர்ல என்ன ரூல், ரைட் ஹேண்டா லெஃப்ட் ஹேண்டா, சிமிலர்லி மோட்டர்ல லெஃப்டா ரைட் ஹேண்ட் கன்ஃபியூஸ் ஆவாங்க. அதை அவாய்ட் பண்ணணும் அப்படின்னா இட்ஸ் a very simple idea to remember students. Okay, so F or H R ரெண்டு ஆர் இருக்கு, ஜென்ரேட்டர்ல ரெண்டு ஆர் இருக்கு. Hence we use Fleming's right hand rule. This rule helps you to find out direction of the current. Okay, hope you understand this now. Then difference between the same thing, left hand rule and right hand rule. This left hand rule is applied for motors and right hand rule is applied for generators to determine the direction of induced current. Correct. And then same thing, we discussed. Correct. Then see here, we know the flux relationship. First, in detail we understand what is flux. Flux is dot product of magnetic field intensity and area vector. Okay, B vector and A vector. Dot product means we will get cos omega t. And this flux depends upon number of conductors. Hence, I include if it is n number of if the circuit is having n number of conductors, it will be having NBA cos omega t. Correct. Similarly, according to Faraday's law of electromagnetic induction principle, E is equal to d phi by dt. Correct. Induced EMF is based on the rate of change of flux, d phi by dt, how flux varies with the time. Okay, hence E is equal to d phi by dt. After I differentiate this, I will get NBA omega into sin omega t. Remember this two quantities, phi and induced EMF, so that we'll understand the generation principle. Okay, in this, no, N and S are two magnets. There will be magnetic field. The magnetic field lines வந்து எங்க இருந்திருக்கும் n ல இருந்து s ல மூவ் ஆகும். Correct. Suppose there is a 5 cases. Correct. First case ல வந்து ஒரு loop of single loop conductor is placed like this. Okay. Then 5 cases similarly. Okay. So first we will discuss about what is phi value, what is E value. Okay. B actually flux is nothing but B vector dot A vector. Dot product expand பண்ணா cos omega t வரும். This omega t is nothing but angle between the B vector and A vector. Magnetic field direction வந்து இந்த directionல இருக்கு. Correct. இப்போ A vector ஓட direction கண்டுபிடிக்கணும். So for any that is loop, correct, for any loop the area vector எப்படி act ஆகும்னா area vector is nothing but normal to the surface area. Normal is nothing but perpendicular. So in the arrow mark வந்து is it normal to the surface area? Correct. This is A vector now. And if the loop is placed like this, okay, this is your area vector, okay, which is perpendicular to the surface. So இது A vector ஓட direction. இந்த மாதிரி இருந்தா இதான் A vector ஓட direction. இந்த எல்லாமே வந்து பாத்தீங்கன்னா 0 degree, 90 degree rotation, 180 degree rotation, 270 degree rotation and 360 degree rotation. Okay. So இதான் initial position இருந்து மறுபடியும் அதே பொசிஷனுக்கு வருது. Okay. So for each case the area vector A vector is acting perpendicular to the surface. Now what is omega t? Angle between magnetic field and area vector. Now in this case, first case, what is the angle? What theta is equal to omega t is equal to 0, correct? Omega t is equal to 0. So first let me do this one. First the angle is for this case, first angle is equal to 0, correct? Then what about flux? Second case is for flux. See, cos 0 is, if you substitute here, cos 0 is 1, hence we will get BA, correct? Or NBA. Okay, so I'll put here it is NBA, okay, which is a maximum value, correct? And then what about E? Induced EMF, third one is E. NBA omega sin omega t, correct? So it is sin omega t. If you substitute 0 in the sin term, it becomes 0. So induced EMF will be 0 when a loop is placed like this. Okay. But flux value will be maximum. Correct. But rate of change of flux is 0. Now coming to this part. Okay. The second case. What is the theta value? Magnetic field is, see here, magnetic field is horizontal, moving from N to S, correct, in this direction. Okay. Area vector is pointing upward, correct. So direction 90 degree, correct. So theta is equal to 90 degree. And then if you take phi value, if you substitute cos 90, its value will be 0, correct. What about induced EMF? It's a sin 90, its value will be maximum, correct? So N, B, A, omega, clear? So maximum value. So flux will be induced in the conductor. Here flux will be 0, correct? But induced EMF will be maximum if you keep your single loop conductor like this in the magnetic field. Okay, that should be very strong in your mind. Okay, so இந்த மாதிரி வச்சோம்னா flux அதிகமா இந்த surface வழியா areas இந்த surface area வழியா போகும், பட் rate of change of flux வந்து 0. பட் இந்த மாதிரி இருக்கும்போது rate of change of flux அதிகமா இருக்கும், ஆனா flux will be 0. Flux are passing through the surface area is 0. Correct. Same manner I am making the same loop in some other rotation. Correct. So next, if I do this 180 degree, correct. So suppose if I give current, that is a loop, a single loop and 180 degree rotation. So 180 degree, correct. I'm making 180 degree rotation. Now see here, cos 180 is minus 1BA, correct. So minus NBA, correct. At the time, what about sine 180? Its value is 0. So rate of change of flux will be 0. Okay, so induced EMF is 0. Okay, then similarly again I'll give the rotation is 270, correct. The next angle is 270. Okay, then for 270, cos omega t, flux will be, for this flux will be 0, but induced EMF will be maximum, but its value is minus NBA omega, correct. Again same case you will get here also, correct. Now uh, the fifth case is 360 degree. 360 degree means again it will be same as the first case. Okay, so what does it mean? When the coils are placed vertically like this, okay, flux are passing through the area will be more and induced EMF in the coil is 0. எப்போ maximum இருக்கும்? இந்த இடத்துல, if it is kept in parallel, then induced EMF will be maximum. Based on the inference what we had in the previous, no, I'm going to draw induced EMF waveform, correct. So now see here we have our maximum. One second. Yes, flux will be maximum at 0 degree. This is omega t value. See here 0, 90 degree, 180, 270, 360. When it is 0 degree, see here 0 degree. This is a 0 degree position, correct. This is a 0 degree position, and then this is 0 degree, and this 90 degree of rotation, and this is 180 degree of rotation, and similarly this is 270, another one is 270, 360. Okay, so now see here the single loop conductors, no, is vertically placed. So induced EMF what is 0 value, so inga irukum, correct. One it is 90 degree moved. See AB, conductor side AB and CD is have the rotation of 90 degree, correct. AB in the pakam irukku, anyhow it is in horizontal, correct. So now the induced EMF will be for 90 degree, induced EMF will be maximum, correct. So now it will be maximum at this point. Okay, so it will be increasing during this rotation from 0 to 90, no, the value will be increasing. Okay, the value will be increasing, correct. Then again when it is comes from 90 to 180, correct. See 90 to 180, its value will be 0. Okay, induced EMF, I'm saying only induced EMF value will be 0, correct. At 180 its value is 0, and minus 270 its value is negative, so I'll get here maximum, negative maximum, and 360 again it will be 0. See here 360 its vertical position, so induced EMF in the conductors will be 0. So if I join this, I'll get, correct. See here. So if you do one rotation from 0 to 360 degree, the induced EMF will be a sinusoidal wave. The sinusoidal wave is nothing but alternating one, correct. So what comes in your mind? அப்போ ஒரு சிங்கிள் கண்டக்டர் லூப்பை மேக்னெட்டிக் ஃபீல்டில் ரொட்டேட் பண்ணும்போது we have only alternating current, correct. But the DC generates DC, correct. That is because of this split rings. What is the other name? Commutator. What is the function of commutator? Which converts AC into DC, which is nothing but this allows current to flow to the load in unidirectional way. That is current direction regardless of the conductor position, no, the current direction is always from L to M. Okay, L ல இருந்து M க்கு தான் போகும். See here, the coil sides A, B and C, D. Correct? Other the current direction is downwards. It is flowing from L to M. Correct? Suppose the after 180 degree of rotation, the conductors AB are this side. Correct? Still the current direction, see here, current direction is downwards and it is moving from L to M. Okay. Unidirectional current அப்படின்னா என்னன்னா, the current flowing to the load வந்து ஒரே directionல இருக்கும். Hence it is called as unidirectional current. Hence we can say it generates DC. This is because of the split rings. Okay, split rings are commutator which are attached to the conductor. Okay, this is nothing but brush. Purpose of brush is to just collect the current from the conductor. Correct? See here, the commutator connected to the CD is also changing its position. That's why we are getting the unidirectional current. Hence, we can say the DC generator uh, sends the DC current or unidirectional current to the load. Okay, the current direction is, as I already said, is decided based on the Fleming's right hand rule. How you decide right hand rule? Generator is having two R. So if you are confusing like that, you can easily remember. Okay. Hope you will understand the principle of DC generator. Okay. Thank you all for watching this.